let's take a look at an example here. We have a 2 by 2 matrix A. We want to find the inverse of matrix A if we can, right? So to do that, we are going to take matrix A, and then we're going to stick it in an augmented matrix with the identity matrix. In this case, it'd be the 2 by 2 identity matrix, right? So that means we have -3, 1, -4, 1 on the left side of the augmented matrix. And on the right side, the 2 by 2 identity matrix, 1, 0, 0, 1. And our goal is to try to transform this into the identity matrix. And we're going to do that by just getting into reduced row echelon form. Okay? We want this as the identity matrix, if we can. All right? So to do that, I am going to start by, let's get a 0 down here, okay? I do need to turn this into a 1, but I'm going to hold off on that because I don't want to turn it into a fraction yet. I don't want these to be fractions yet, all right? So let's do 4 times row 1 minus 3 times row 2. That's going to be my new row 2. Okay, and the goal is to get a 0 here. I'm leaving row 1 the same. And row 2, I'm going to get 4 times this is going to be -12 minus 3 times this. So minus 3 times -4 is +12. I do get 0, which is good. 4 times 1 minus 3 times 1 is just 1. 4 times 1 plus minus 3 times 0 is 4. 4 times 0 minus 3 times 1 is -3. Okay? So we've started to get that stair-step pattern. All right. In row 2, I've already got a leading entry of 1 there. So now let's just get a 0 above it. So I'm going to take negative row 2, add it to row 1. That's going to be my new row 1. Okay. So -0 plus -3 is -3. -1 plus 1 is 0. -4 plus 1 is -3. And +3 plus 0 is 3. All right, and we're leaving, for now, row 2 the same. We're almost done. We just need this to be a 1 instead of a -3. So I'm just going to take row 1 and multiply it by -1/3. And look at that, we were able to avoid fractions the whole way through because row 1 is going to become 1, 0, 1, -1, and row 2 becomes, or stays, 0, 1, 4, -3. We were able to transform the left-hand side of this augmented matrix into the identity matrix. That means the matrix is invertible, and it means that this, on the other side of the augmented matrix, is the inverse. And just to prove it to you, let's multiply our original matrix A with A inverse right over here. So our original matrix A was right here. So here's our check. A times A inverse is equal to our original matrix A times A inverse, which we found was 1, 4, -1, -3. So if I take first row, first column, take the dot product of those. I get negative 3 plus 4, that's 1. Second row, first column, take the dot product of those. Negative 4 plus 4 is 0. First row, second column, take the dot product of those. I get 3 plus negative 3, that's 0. And second row, second column, take the dot product of those. I get positive 4 plus negative 3, that's 1. And so it checks out. This matrix is indeed the inverse of matrix A.